Welcome to the course Business Analytics and Text Mining Modeling using Python. So, in the previous lecture we started our discussion on file management in the Python platform. So, we will just quickly go through some of the things that we discussed in the previous lecture, and then we will pick up from the point where we stopped. So, as we said that working with the files in Python platform is quite simple, and Python is quite actually popular for text processing and file munging. And we talked about opening a file, which is the first probably first thing that we typically do in file management. There are different operational modes. So, if we just use the function open and we just pass on the file name as the argument, for example temp1.txt, then by default the file is going to be opened in the read only mode, that is R within single quotes. So, what I will do, this part we have discussed in the previous lecture. So, I will just run through this. So, if the file does not already exist, then we get the error. In this case it is there. Let us take temp.txt, then if we want to read the contents of this file. So, you can see in this case probably in the previous read we have already read all the contents that was there in the file. So, we got the empty bytes object here, and you can see end of the line is already reached. Now, closing the file objects, fl3.close, close is the function as we discussed in the previous lecture. If iterating over the lines in a file, then again if you want to iterate over the line and print the line, and will end of line marker is by default /n. So, each of those lines are going to be printed in a different line. So, that is there. Then there is another method, closed method, which will tell us about whether the file is opened or closed. So, I will just run through this. Then if we want end of line free list of lines. So, in this case because we have already read these, so the output is slightly different. Then cleaning up this file. So, we can use the bit block, so where automatic cleaning happens. And so, if the file is closed, then we will typically get this error IO operation on closed file. Then we move on to the next thing. So, I think we were discussing this part in the previous lecture. We stopped at this point. So, Python file modes for writing. So, there are three different modes that are typically used for writing. So, W, that is for write only mode. So, if there is already a file with the same name, that is going to be erased, in the sense the data would be lost. Then there is another file mode X, that is also write only mode, but if the file with the same name is already existing, then this if we open the file using this mode, that will fail. And then we have the another file mode A, this is also for writing. So, if file does not exist already, that file is going to be created, but if the file is already existing, any data that we want to write, that is going to be appended at the end of the line, at the end of the file. So, these are the three popular modes. So, let us open this file temp.txt in the A mode. So, we would be appending here, and you can see the 9 output that we have, that we are seeing here is actually the number of characters that are part of the string that we have written. So, that is returned. So, let us close this file, and now we can use another method, read lines. So, that can be used to store all the lines that are there in this file. So, if I run this and again lines. So, now you can see the appended this has been written in the file. So, that is displayed. Now, let us open this file in the next file mode, that is W, that is write only. So, because this file is already there and we have the data appended there. So, if I run this again, we will lose this data, and if I try to read the content here, not readable, because the file is open in the write only mode. So, I will have to close this file object and then again open it for the reading. So, you can see, and you can see the empty bytes object is written in the output number 65, because we use the write mode there. So therefore all the data that was part of the file, that was erased out. Now the next file mode is X. So let's take an example for this one also. So we are opening temp.txt in this file mode X. So if I run this, so this will fail. You can see the error number 17, file exists. So if the file is already existing, this opening of this particular file object will fail, this particular file will fail in the X file mode. So now let's move to the next example. So here we are opening another file temp1.txt. So if I run this, so in this case also file is already existing. So again this will fail. Now if I open in the append a file mode, then this file will open and I can add this line. So now I can add this line and this would be appended at the end of the file. So I am going to write this string Om Namah Shivaya, and if I run this, so you can see in the output we have 16, that is the number of characters that have been written there. So what we'll do, we'll run it 1 or 2 more times. So we are just writing few lines in that file. So now let's close this file, and if we open this for we can open this for reading here. Now let's talk about the methods which are typically used in the read modes. So there are 3 methods that could be useful: read, seek and tell. Let's understand few more aspects about reading data files. So by default bytes from a file are decoded to Unicode. So that is the default file encoding. So depending on the platform, this default file encoding can actually change. So however Unicode remains the one of the common default file encoding, and this is actually a text mode for files. So by default we get, by default the default mode is text mode, and in that case the file the bytes from a file are recorded into the to Unicode. And what constitutes a character, that is actually determine the kind of encoding that we might be using. So UTF-8 is the one of the most popular Unicode format that we have. So let's understand some of these aspects through examples. So let's take read method first. So we have talked little bit about read method before also, but we'll use different examples here. So read method, it will advance the file handle's position by the number of bytes that have been read. So first thing is, whenever we apply read method, this file position will be advanced. So that is why in the previous example that we have seen, and in the previous lecture, in this lecture as well as in the previous lecture, once we call this read method, then data is going to be read. However, the file position will also change. So if whenever we have called that read method again, we have got the empty bytes object, because we have been reading all the data in a file till now. We have not specified the number of characters that we would like to read, rather all the characters we have been reading. So whenever we have called that read method again, we have got the empty bytes object, because file handle's position will be changed by the number of bytes read. So if you read all the bytes, it will reach at the end of the file and the empty bytes object would be returned. So in this case, you can see we are using this example fl6.read and 9. So we would like to, the argument that we are passing is having this value 9. So that means we would like to read 9 characters here. So if I run this, you can see I have got this string Om Namah and then space total. If you count the characters here, then it comes out to be 9. Now there is another file mode so the default file mode is text mode, and where the bytes are typically encoded using the Unicode format. So the another file mode is the binary mode. So this is typically used to read raw bytes. So whenever we want to actually read the data the way it is written in the raw form, then we can use this binary mode form B is used. and read method will actually returns the exact number of bytes that have been read. If the file is opened for open in the binary mode, then exact number of bytes in this particular file mode is returned. If you remember what I said for for the text mode, that the number of bytes the file position moves by the number of bytes read. So, for a given number of characters that we might want to read in the text mode, the number of bytes might be more than that, more than the number of characters that we might have read. So, therefore, there the file position will change slightly differently, might change slightly differently depending on the encoding that we might have used. However, in the binary mode, it is actually the exact number of bytes. So, when we open the file in the binary mode, let us take an example FL7, and we are opening this file temp2.txt comma rb. So, we are we have appended this b in the read mode. So, now this is read, we are opening the file for the reading, but in the binary mode. Now, we are asking to read 9 bytes, not 9 characters, because the file is going to be opened in the binary mode. So, when we call this method fl7.read and pass this argument 9, this is actually about reading 9 bytes, and that too in the raw form. So, if I run this, in the output you can see the output is is prefixed with b, that is to indicate that the data that is coming after that b is in the binary mode in the raw form. So, you can see b om namah. So, in this case there is no problem, and because the encoding is such that the characters that we have printed, there is no problem, the output is very similar to what we had in the text mode. So, one difference is the mode. Default mode is text mode, another mode is binary mode. So, in the text mode the file position might be changes differently, because we would be reading number of characters. In the binary mode we would be reading number of bytes. So, file positions changes accordingly. Now, let us talk about the another method that we have here, tell method. So, what this method does, this method gives the current position of the file handle. So, this is typically an integer value. So, if I look at the FL6 file object that we had created. So, if I call this tell method, so let us find out what is the current position of the file handle for this file object. So, if I run this, you can see 9, because the previous operation that we had done using this file object fl6.read 9, we had read 9 characters there, and the current position of the file handle is 9. So, probably to encode those 9 characters we require just 9 bytes. So, that is why this is the position now. So, this is an integer value. So, whenever we call this tell method, we get the current position and integer value. Similarly, for FL17 also, if I run this, so FL7 this file object was open in the binary mode, and there also we had read 9 bytes there. So, the current position for this one also, if you look at the output number 79. So, the current position of file handle in this case also is 9, because there was the way encoding is there, the number of characters and the number of bytes required to encode those characters are equal. So, that is why we are getting the same number as output. However, this might not be the case if we change the encoding, text encoding. Now, sometimes we might be required to check the default encoding that is being used. So, in the open function that we have, so if you just go to the Python reference. So, as we have said before also, sometimes it might be really useful to refer to the manual pages of these functions. So, let us take an example here, open. If I try to find out here more details about the open. So, you can see in this we have this Python function, built-in function. So, this is what we are using here. So, you can see there are various arguments that can be passed on to this function. You can see file, then mode, then buffering, then encoding. You can see the encoding is also there. By default it is none, right. So, that means it is the system's encoding that is going to be used. If you want more detail about encoding, you can scroll down and find out where they have the discussion on encoding in this man page. So you can see here, you can see here encoding is the name of the encoding used to decode or encode the file. This should only be used in text mode. So this particular argument is only to be used in the text mode, because it is in the text mode that we would like to use different types of encoding, and in the binary mode it's we just want to read the data in the raw form. So therefore this argument is not applicable there. However, if the value encoding is argument has not been used, and so the default value is none. So therefore systems platforms default encoding is going to be used in this case. So let's go back. So let's find out what is the default encoding that we have here. So for this we'll use the sys module, that is that help us in terms of to understanding the default system settings as well. So let's run this, import sys and then sys dot get default encoding. If I run this, you can see UTF-8. So it is the this Unicode UTF-8 format, the most common the most common Unicode format is being used here. Now let's talk about the another method, seek. So what this method does, it changes the file position to the indicated byte, so an integer value. So we can pass on an integer value, so that integer value would actually be indicating a byte where we would like to move the file position. The seek method can actually be used to perform this particular task. So let's take this file object fl6 and dot seek method, and we pass on the value 5. So the file position is going to be moved to this particular byte number. So if I run this, and the output is 5 here, and now if I try to read from this file object, fl6 dot read 1. So I would like to read just one character here. So you can see m, I'm able to read m. So earlier output, if you go back and see what was the earlier output that we have. So this string is ohm number. So if you see that fifth character is m actually. So that is why when we change the file position using the seek method, and when we read the first just one character from there, then it was m. Now let's close these two file objects. Now let's talk about few more scenarios here. So there are two more useful methods, write lines and read lines. So these two methods, especially the read lines method, we have used before also. Now I'll discuss them in more detail here. So write lines method, this is actually used to write the past sequence of a string to the file. So if we have a certain sequence of a string, so this particular method write lines can be used to write all those lines in one go, and those lines sequence of strings can be written in the file. So let's take an example. So what we'll do, we'll use this temp2.txt. There we already have certain data there, and if I we are using the bit block here, so we can open this temp3.txt in the write mode. So whatever is there, whatever data is there in the temp3.txt, that will be erased, and this fl8 object is going to be created. And now we are using this method fl8 dot write lines, and here you can see I am using a comprehension here. So x for x in open path 1 if length greater than 1. So if there are multiple lines there in the file, and there might be certain lines that certain lines with no characters there. So only the lines which are having more than one character, those are going to be filtered and then written here. So if I run this, and again I open this file, and this time this temp3 dot file I am using a read lines method here. So, here if I run this, so you can see and lines. So, all the lines that are there in this FL8 object that we have just written, those would be stored in the lines variable. So, you can see here all these all these lines. So, if there was any lines, you remember that previously when we had created this file, we had the empty bytes object. So, that has been filtered out from here, and you can see the main idea is to demonstrate how read lines method can be used. So, in one go we have been able to read all the lines here. So, it is like a for loop is running, we are iterating over all the lines that are there. Similarly, when we use write lines, there also similar kind of thing we can use. Let us move to the next aspect here, bytes and Unicode with files. So, let us talk about a few details about these aspects. So, Unicode format we have already talked about. The default, this is typically the default text encoding that is used in the most platform, and there also UTF-8 is the more popular. And if we talk about UTF-8, this is a variable length Unicode encoding. So, in this when we are requesting some number of characters from the file, like we did in the in few examples before. So, this is typically done in the default text mode as we have discussed. Then the Python, what will Python do? It will read enough bytes from the file to decode that many characters. So, previously we had called this method read, and we said that the number of characters that we want to read. So, we can pass on that as an argument. So, but depending on the encoding that might have been used, the Python will try to read those many number of bytes that are required to read the specified number of characters. So, that is the idea that we would like to demonstrate here if possible. So, we have the bit block here, and in this bit block we are opening this file as this FL8 object, and then we are calling this read method, and just 9 characters we want to read from this file, and then these 9 characters are going to be stored in this cars variable here. So, if I run this, and if I just run this cards again, access what is there, you can see Om Nama. So, and then the space is also there, trailing space is there. So, 9 characters we have read from this file. So, depend, because in this case the default encoding is UTF-8. So, therefore, to be able to read 9 characters we require Python is required to read just the 9 bytes. But it might so happen that for some other text encoding, a more number of bytes might be required to be able to read 9 characters. So, in that case number of bytes will increase. So, it depends on the text encoding. Now, when we are as we have discussed when we use the read method, that when we are requesting, when we have opened the file in the binary mode and we are requesting certain number of bytes to be read, then in the binary mode Python is going to read the exact number of bytes as we have discussed before. So, let us have this block with open path 1 and the binary mode RB we have indicated as FL8 colon, and then raw we are initializing this variable raw, and we are reading 9 bytes here, FL8 dot read 9 bytes here. So, all these 9 bytes are going to be read and they are going to be stored in the raw variable here. So, if I run this block of code, so we will have raw. So, let us execute this one and find out what is there. So, as we have seen before, you can see in the output is the whole number of bytes that have been read. It is prefixed with the B to indicate that we are into the binary mode here, and Om Nama and the 9 characters. So, in this case because of the in this case because of the characters that are being used here, 9 bytes are actually enough to be able to whether we read 9 bytes or whether we read 9 characters, that means whether we are into the text mode or whether we are into the binary mode, because the encoding is such, the characters that we are using are such that to constitute them we just require 9 bytes. So, in this case whether we have opened the file in the text mode or we have opened the file in the binary mode, the output is same. However, if we use a character maybe in some other language, Latin or something, or in some other western languages or Indian languages, and for that some of those characters, if more number of bytes are required to constitute that character, then in that case you would see clear difference in the output, in the sense that if we say 9 bytes, then we won't get the full string, and if we say 9 characters, then we will get the full string, but probably Python will have to read more bytes. So, that is the idea that we wanted to demonstrate. Now, let us move into the next aspect here, that is about decoding the bytes to a string object. Now, this particular thing is possible if each of the encoded Unicode characters is fully formed given a particular text encoding. So, depending on a text encoding that is in use, so it is possible that bytes can be decoded into a string object. However, it will be possible only if the encoded unique code characters are fully formed. That means if a particular character requires more than 1 byte and the number of bytes that we wanted to decode it could not cover that character, then this particular thing would fail. But if we were able to form that character, all the bytes that were required to constitute that character, they were part of the bytes that we were decoding, then this will succeed. So, the method that we typically call is decode. So, raw is the object that we have read all those 9 bytes, and then we are calling decode method, and UTF-8 is the text encoding that we are using here. So, if I run this, we will get om namah here, because whatever we had in raw, that was already as per in the compliant with the UTF-8 format. So, we got all the characters here. Now, if I try to access raw and just up to I take a subset here, and I just focus on 5 5 bytes here and decode, then let us see. You can see, because in this case there is no problem, we do not have any character which requires more number of bytes, more than 1 byte. So, therefore, no problem, we got om space na. So, we have got 5 characters here. Similarly, next one raw 4, if I decode, you can see 4 characters, no problem. Raw 3, no issues, 3 characters, om then space. Then let us take another example. Here what we will do, we will create a file temp4.txt, and in this case we will write a different string which will probably hopefully will require more number of bytes to constitute the character. So, you can see we are typing, we are writing new base here. So, you can see I in this new is coming from different language. So, maybe it will require more number of bytes. So, let us run this block of code, part 2 tempo.txt, then we have this bit block, and we would like to write this new base there. Then let us open this file in the binary mode for reading. So, we will have raw 2 as our variable here, and let us print this. So, you can see in the output number 97 here, you can see B is prefixed to indicate that this is in binary mode, we are in binary mode, and then you can see the output here N and A. Then for I, you can see different kind of characters are there. So, if you can see 1 2 3 4 bytes, probably 4 bytes are required to constitute the character I with double dots that is there. So, this is the output. Now, if I move to if I just decode 2 bytes here, we get NA, no problem. If I try to decode 3 bytes, now if I try to decode 3 bytes, we are running into that character I with double dot. So, if I run this, you can see I got this error, unexpected end of data, because for I double dot, we require 4 bytes. However, we just try to decode 3 3 bytes. That means only 1 byte that is constituting the I double dot is part of this data that we want to decode. So, therefore, unexpected end of data, that is the error. So, this is what I wanted to demonstrate, that this can happen. Now, let us take the full data here and try to decode. Then you can see. Now, after we run into this kind of problem where our file position is in middle of some character, where middle of some character which requires more than 1 byte, then we might get these kind of error, invalid continuation byte, because Python is not able to continue from there, because it is lying in between somewhere. Now, we have raw 2 and now we are changing the encoding here. So, you can see I have changed the encoding from UTF-8 to Windows hyphen 1250. So, let us see if we use this encoding, what is the output. So, if I run this, you can see the output is slightly changed. So, maybe in this text encoding that I have just used, those those bytes, those raw bytes, they constitute a different character. So, in this case you can see the apostrophe kind of character has been constituted here using this particular text encoding. Now, if I change the text encoding to Windows 1252 in the next line, if I run this, then you can see we got this neo B here appropriately. So, this is working here. Now, when we are using this text encoding Windows 1252, and again we do the same thing, we try to access 3 bytes here, so in a sense here we do not face any problem. Now, let us move into the another aspect. Sometimes we might be required to convert from one text encoding to another. So, let us take an example here. So, here we can use 2 bit blocks, inner and outer, and we can easily run through convert the data from one mode to another mode. So, we have temp.txt and then we are opening this path to this that we have created before as FL8 object. Then another bit block open temp path and xt mode, and we are encoding into different so default encoding will be in the UTF-8, and the new encoding would be Windows 1258. And then what we are doing is all the lines from the one encoding, they are going to be read, and then we would be writing that into the new encoding. So, we will be creating new object FL9. So, there we would have written the lines in this new encoding. So, let us run this. This is how we can do this. So, in this case we have run into some error. So, let me resolve this. So, we have opened this in the xt format. So, that we can change here. So, let us fix this error. So, what we will do, so if we do not want to change the code, so what we will do, I will just delete this file from here, and once deleted then we will not have any problem. So, let us go back, and if I run the same code again, then it is okay. And now, what we will do, we will read whatever we have written, and we have written in different encoding. So, first we read line by line from the every line in the original encoding, and then written in the another encoding. So, let us run this. You can see now neo B. So, encoding has been changed. So, we can convert we can convert file from one text encoding to another. Now, let us focus on another aspect. So, this is rather a caution note. This is related to the seek method that we have discussed, and this particular aspect is mainly applicable to the non-binary file modes. So, what happens is that if the file position, as we have seen in previous example, file position might fall into in the middle of bytes defining character, like we did in the I double dot character. We ran into that middle of the bytes kind of thing. So when such a thing happen, so as per a so what might happen, subsequent reads that we might perform, they might result in an error. So in this case, you can see, let us take an example with open temp5.txt in the write mode, and we will write this particular string value here. So let us run this, and so now this example might work or might not work depending on the text encoding that we are dealing with here. So let us open this file for reading, and you can see this string has been written. Now if I try to, so because this caution note is this particular aspect is related to seek method. So let me seek into this particular file position 4. So if I run this fl8.seek 4, then if I try to read whether I run into the problem or not. So in this case there is no problem, because if the file position falls into the middle of the bytes only, then this situation will occur. Otherwise it will just go smooth. So in this case it was not the problem. However, the previous example that we have gone through, where we are having naive base and I double dot character, so there you had seen that the read of that particular line failed. So that concludes our built-in capability aspects of Python language. And now I would like to stop here, and in the next lecture we will talk about the next module, NumPy. Thank you.